Chapter 13. We're going to combine the first three lessons together because they're all about sequences. So we want to learn to identify and find terms in sequences. And our essential question, how do I determine the type of sequence? A sequence is an ordered list of numbers or objects. Each number of objects in a sequence is called a term. In an arithmetic sequence, the difference between one term and the next is always the same. This difference is called the common difference. The common difference is added to each term to get the next term. Determine if the sequence could be arithmetic. If so, give the common difference. So we are looking for if we can add a number to get from one to the other. Now remember, we could be adding a positive or a negative number here. So we look at the difference between 5 and 8. We look at the difference between 8 and 11, and so on, all the way through the sequence of what we have. And we're noticing that the terms increase by 3 every time. So this sequence could be arithmetic with a common difference of 3. Let's check another one. Determine if the sequence could be arithmetic. So we're simply looking for if we can add a common number for each term. But here we're adding 2, then 3, then 4, then 5. Even though that's a pattern, it's not the same number every time. So this is not a common difference and it is not arithmetic. Find the next 3 terms in the arithmetic sequence. This is telling us that it's arithmetic, so we know that we are adding the common difference each time. Each term is 5 more than the previous term. So to find the next 3 terms, we would add 5 to 7 and get 12. Then we would add 5 to 12 to get 17. Then we would add 5 to 17 to get 22. So our next 3 terms in the list would be 12, 17, and 22. We can do this in an equation format too. If we're looking for the nth term, which means any number down the road, we could be looking for the 5th term, the 100th term, the 1000th term. A sub n of an arithmetic sequence with a common difference d and the first term a1 looks like this. A sub n equals a sub 1 plus the quantity n minus 1 times d. So let's break that down. A sub n is what the answer of the term is. N is the number of the term you're looking for. So if you're looking for the 100th term, n would be 100. A sub 1 is the first term in the sequence, and d is the common difference. So let's try it out. Find the given term in the arithmetic sequence. 10th term. We could just go and list these out, but let's try the formula. So since we're looking for the 10th term, it's a sub 10, which just helps us mark what term we're looking for. That's not an actual answer. A sub 1 is 1 because 1 is the first term in the sequence right here. N would be 10 because it's the 10th term. Minus 1 is always part of the formula. And D is 2 because we're adding 2 every time we get a new value. So we use order of operations to subtract 10 minus 1, multiply by 2, and add 1 to that. So A sub 10, or the 10th term in the sequence, would be 19. Now if we want the 50th term, and this is arithmetic, so we know to use this formula, A sub 50 equals 100 because 100 is the first term. 50 is the nth term, or n, minus 1, times negative 7. And it's a negative because we are decreasing. So we take 50 minus 1 times negative 7 plus 100 and get negative 243 for our 50th term. Let's look at a second kind of sequence, geometric. In a geometric sequence, the ratio of one term to the next is always the same. This ratio is called the common ratio. The common ratio is multiplied by each term to get the next term. So you can see our vocabulary fits in exactly like it should. Common difference is when we are adding and subtracting numbers. Common ratio is when we are multiplying or somewhat dividing. Determine if the sequence could be geometric. So we're no longer thinking arithmetic, we're thinking, is there something that we have in common with multiplication? So we look. Oops, sorry. So those should be fractions. So it's a little bit skewed, sorry. But from 1 to 3, we're multiplying by 3. From 3 to 9, we're multiplying by 3. From 9 to 12, we're multiplying by 4/3. From 12 to 15, we're multiplying by 5/4. And you can get that number by dividing 15 by 12, 12 by 9, 9 by 3, but the pattern is not the same all the way through, so this is not geometric. Let's check this one. We have a common ratio of -2. Every time we multiply, we're multiplying by -2, so that's why the negatives and positives alternate, and our common ratio would be -2 because this is geometric. We have a formula for geometric as well. The nth term, or a sub n, of a geometric sequence with a common ratio r is a sub n equals a1 times r to the n minus 1. We want to find the 11th term. So if we look at this in terms of the formula, first we need to get the common ratio. Well, 4 divided by -2 is -2. That's our common ratio. Now we plug our numbers in. A sub 11 equals -2, because that's the first term, times the ratio of -2 to the 10th power, because our power will be the term minus 1. We do the exponent first. That's how we get 1024. And we multiply by -2 to get -2048. For the 9th term, if we don't know what our common ratio is, we take the second term divided by the first term. So 70 divided by 100 is 0.7. A sub 9 equals 100 times 0.7, the ratio, to the 8th power. We take 0.7 to the 8th power and get that nice long decimal, times 100. We get 5.764801. And let's look at another type of sequence. There can be sequences that just have different patterns. They may not be the same difference every time. They may not be the same ratio, but there still might be a pattern there. So we look at what are called first and second differences. Here are triangular numbers, starting with 1, 3, 6, 10, 15. These are triangular numbers because you can have that many dots and form a triangle. Each time we're just adding one additional one to the next row. To continue the sequence, you can draw the triangles or look for a pattern by using first and second differences. The first differences of a sequence are found by subtracting each term from the one after it. Second differences are found by subtracting the first difference from the one after it. So we have 7 terms in our triangular numbers. For our first differences, we look at the difference between 1, 3, 6, 10, 15, 21, 28. So there, it goes from 2 to 3 to 4. We're adding 1 each time. Second difference shows that commonality. So our second difference breaks down what our pattern and our first differences are. Use first and second differences to find the next 3 terms in the sequence. So we start with our sequence and our first differences. It'll be 7, 11, 15, and 19. Now we're looking for what's the pattern in those. When we break it down further, we notice each one of those is increasing by 4. So to find the next number, we would add 4 to the first difference to get 23, and we would add 23 to the sequence to get 76. We would do that another time. Add 4 now to 23 to get 27. 27 plus 76 is 103. Add 4 to 27 for 31. Add 31 to 103 for 134. So sometimes we have to dig a little bit deeper. Give the next 3 terms in the sequence using the simplest rule you can find. It doesn't have to be complex. You can look at these as numerators and denominators. So in the numerators, it goes 2, 3, 4, 5, 6. Denominators 5, 7, 9, 11, 13. So we're adding 1 to the numerator, and we're increasing that denominator by 2. We're not worried about writing any algebraic rules right now, but that's showing exactly what we would be doing. So 7 fifteenths, 8 17ths, and 9 19ths. Give the next 3 terms in the sequence using the simplest rule you can find. If you notice the pattern there, it said start with 1. Use the pattern of adding 10, subtracting 5, adding 10, subtracting 5 to get 16, 26, 21. Let's find the first 5 terms of the sequence defined by a sub n equals n parentheses n minus 2. N represents the number of the term. So if we're looking for the first term, we replace n with the number 1. We use order of operations, we solve, we get -1. For the second term, we replace n with 2. We use order of operations, we solve, we get 0. For the third term, n would be 3. Order of operations, solve, we get 3. Fourth term, n would be 4. Order of operations, solve, we get 8. And the fifth term, n would be 5. Order of operations, solve, we get 15. So here are our first 5 terms. That's a lot of different information, arithmetic, geometric, and then using first and second differences to try to find some of the patterns in sequences that maybe don't fit the first 2 categories. Also, learning how to plug in different term numbers to find different results. So look back at anything you might need to, make sure your notes are filled out thoroughly, and good luck on any practice that you do.